In 1993, the Institute of Aeronautics and Astronautics, National Zhongzheng University, was established under strong governmental support. To establish the institute, a good portion of equipment funding was allocated for large-scale experimental facilities. Therefore, a sugarcane field in the Guiran district, 15 kilometers from the main campus of the university, was chosen and named Aerospace Experimentation Field. The Aerospace Experimentation Field was renamed Aerospace Science and Technology Research Center in 1993, separate from the Institute of Aeronautics and Astronautics as a research institute. Nevertheless, the relation between the two institutes remains very close as ever. To date, the major facilities situated in this field include wind tunnels, a combustion laboratory, and a flow measurement laboratory. In association with the Institute of Aeronautics and Astronautics, the major mission of the Aerospace Science and Technology Research Center is to educate and produce high-quality aerospace engineers with advanced degrees. The center has also developed a close link with the defense research agencies and civil industry in the country. Promoting international collaboration is another important issue. The major facilities for aerodynamic and fluid dynamic research are comprised of a transonic wind tunnel, a low-speed wind tunnel, a shock tunnel, and a flow measurement laboratory. The ASTRC transonic wind tunnel is of a blown-down type, featuring a test cross-section of 600 millimeters by 600 millimeters for Mach numbers between 0.2 and 1.4. The tunnel has a compressed air source whose capacity is 180 cubic meters in volume at pressures up to 50 bars, and the maximum run time at sonic speed is limited to 30 seconds. Calibration of the tunnel was completed in 1993. Since then, the tunnel has been operational for experimental research, including wind tunnel wall interference, transonic turbulence measurement using hot wire anemometry, development of pressure-sensitive paint and liquid crystals, high angle of attack aerodynamics, transonic cavity flows, compressible corner flows, and transonic shock wave and boundary layer interactions. The low-speed wind tunnel is a closed-type tunnel with a constant area test section of 1.22 by 1.83 by 2.77 meters. There are a honeycomb and 5 screens, and the concentration ratio is 9. The turbulence intensity of the free stream flow is about 0.3%. The maximum wind speed is 67 meters per second. The major activities include wind load tests for civil structures, road vehicles, and aircrafts. A shock tunnel was established for generating hypersonic flow fields. The major research activities include supersonic combustion and optical diagnostic technologies. Development of hydrogen-fueled and hydrocarbon-fueled technologies is under progress. A flow measurement system was established for gas meter calibration. The capacity of this system has two ranges of volume flow rates, namely a range of 5 to 1,215 cubic meters per hour for pressures of 207 kilopascals to 2.07 megapascals, with a total uncertainty of 0.31%, and the other of 0.023 to 3.073 cubic meters per hour for the same air pressure range, with a total uncertainty of 0.26%. The capacity mentioned above has been certified by the Taiwan Accreditation Foundation. This system is equipped with two test sections, one of which is designed for testing the flow meters operating at pressures in the range of 2 to 20 bars, and the other is designed for testing the flow meters operating at atmospheric pressure. The combustion laboratory comprises general combustion test cells. The compressed air can be preheated up to 920 degrees Kelvin by a pebble bed heater. The fuel supply subsystem can deliver JP4 fuel to test articles at high pressure and temperatures of up to 420 degrees Kelvin. The nitrogen supply subsystem provides nitrogen gas to the process fluid for reducing the oxygen mole fraction of the compressed air, suitable for stimulating the afterburner inlet conditions. Development of a hybrid rocket, sounding rocket, and pulse detonation engine are among the major research interests. In 2012, the Advanced Satellite Propulsion Laboratory was established in cooperation with the National Space Program Office. Other research activities include heavy oil clean combustion technology, advanced clean combustion technology, renewable energy utilization, and material tests at high temperatures. NCKU is the first university to devote itself to the research and development of a hybrid rocket in Taiwan. A 30 kgf hybrid rocket was successfully launched in May 2009 and reached an altitude of 2 kilometers. A 300 kgf paraffin HPTV N2O rocket was also constructed and launched in mid-October 2009. It reached an altitude of 8 kilometers. The current project seeks to achieve a thrust level of 100 kgf with a 10 kilogram payload and reach 20 kilometers of altitude. The physical and chemical aspects of the lower thermosphere between 100 kilometers and 300 kilometers of altitude have been ignored. Safe, reliable, and low-cost sounding rocket technology for launching a nano-satellite is necessary. Thus, hybrid rocket technique is important potential rocket technology for the lower thermosphere space science program. In addition to the research activities, the Center also supports the activities of the satellite program of the National Space Program Office. The telemetry, tracking, and command ground station for Formosat-1 was built by the National Space Program Office in 1995 and was integrated and verified in April 1997. This station serves to transmit and receive experimental data in high and low rates between the Formosat satellite and ground segments. Since the successful launch of Formosat-1 on January 27, 1999, the TT&C on-site engineers have taken on the routine jobs such as monthly maintenance, quarterly maintenance, semi-yearly maintenance, yearly maintenance, equipment calibration, and engineering correction maintenance to guarantee the best quality of satellite communication. The second TT&C ground station, also located at Guirun campus, has been in operation since 2008. The Aerospace Science and Technology Research Center has successfully accomplished a number of research works and projects in connection with technology development in aerospace and non-aerospace areas. Through these activities, the center has developed a close link with the defense research agencies and civil industry in the country. Future, the center looks forward to playing an even more active role to promote the utilization of aerospace technology for various applications. It should also be mentioned that ASTRC has gained a good deal of experience with regard to international collaboration in the past years, including conducting joint research projects, hosting foreign visiting scholars, and organizing international meetings. As expected, the results and benefits gained from this international cooperation could hardly be replaced by any other means. The center will continue in this direction to promote international activities in the future.